Welcome to Calculus in the Air. I'm your host, Mr. Shandelka. We have an overcast day today, chill morning, about -13. Traffic going down Albert Street is going smoothly. We have some slowdowns in Broad Street and Victoria intersection. Phone in if you have any more traffic reports for me. We'll get those out there, but please be careful. Don't text and drive at the same time. Pull over. Okay, big shout out to A&W. She's not here today. Give her wallet. Anyways, 4.3, estimating slope of the tangent lines at specific points. This lesson has been brought to you by Carlsberg Beans. The taste that brings you back to the campfire. Carlsberg Beans. Quality you can trust. Now, specific points. This is just building on what we've done before. I've got to say that because my sponsor. Anyways, we will learn how to evaluate the slope of a tangent line without using a chart. Now, I have a little mini picture of the other day. This is the same function that we just looked at before I shut down the computer and restarted it, right? And do you remember what this, when we did the chart, we got -2. Wasn't it -2? Yeah, it would be anyways, but I think that, yeah. We did this one the other day with the chart. Now, we've got to now use our imagination a bit, because there's a more precise way. We've got to create or imagine a secant line. Remember, a secant line is a line that cuts, hits twice. And the coordinates of the initial point that we're moving closer and closer to are -1 and 2. So the same as the other day, point P. And then Q is the dot that we keep creeping in and moving closer. And the idea is to put P and Q, or Q on top of the same spot as P. But the problem with that is you're dividing by 0. You can't have divide by 0. So we've got to, calculus allows us to get around the problem of dividing by 0. We don't actually divide by 0, you can't. But we get around that problem. Anyways, so this point, Q, the second point that we're dragging in, instead of actually, you know how the other time we used like -0.99 or -1.01, -0.999999, -1.00001, and we got it closer and closer all the time, right? We could see what it would approach. Well, let's just think of this. Each time I was getting -0.99 and so on, I'm just taking -1 and just moving a little bit away from it for the x value. Agreed? So this h is that little bit, either I'm adding 0.01 to it or I'm subtracting 0.01 to it. So you can still think of subtracting 0.01 as adding h, because adding -0.01. That's what this h represents, that little distance. And the idea is that you're moving Q so close there that this h, other than Hashim, what is the idea? To get that little distance, this h distance, plus 0.00001, closer to 0, and then plus 0.0000001, and so on. Do you guys get that idea? That's what this h represents, that little bit of distance away. Once you have that x value, remember how we plugged it into the function f of -1 plus that little distance away from it. That's what the h represents. So when we create or imagine a secant line, we're not going to actually use the Q, the second point, we're not going to actually use 0.99 or some number like that. We're going to just say it's a number very close to it. We're just adding a little tiny bit to it. So Q has these coordinates, right? Now I'm going to use that fact up here. Now let's figure out what Q, as I mentioned here, is, I'm going to just put it here again, -1 plus h. That's the x coordinate, f of -1 plus h. Now that's generic kind of thing. I don't know what the function is, you could say, but I know it's just plug in that number. We do know what the specific function is in this specific problem, though. It's x squared minus 3. Because we're going to want to do a slope here. You know, x1, q is x2, or has x2, and then y1, y2. y2 is the problem, because we have a y1 value. we have an expression for x2. We want an expression for y2. So let's just see what our second expression is. y2 is going to be equal to, well, f of, well, the function is x squared minus 3 in this case. So I'm going to put, instead of something squared minus 3, I'm going to put negative 1 in here plus h. I'm going to actually evaluate what f of negative 1 plus h is. And then, do a little arithmetic. It's not heinous. It's not. You're going to get used to this. When you square something out like this, you make sure you have 3 terms. Don't do the fool's way and just say 1 plus h squared. I will pop a balloon every time you do that. You hear that? I got a person back there. Anytime you get a wrong answer. 1 plus. Nope, not plus. I'm thinking this is 1 plus h, negative 1 plus h times negative 1 plus h. So minus h, minus 2h. This is when I usually get that mistake too. My board glitch. Plus h squared. Agreed? 3 terms when you square that up. And then subtract 3. That is my y coordinate. Now, let's just group it together a little bit. Sometimes people feel better too if they put the h squared term first. So we'll do that. H squared minus 2h minus 2. Ding dong, what do we do now? Slope. Because the whole point of this, let's not lose sight, estimating the slope of a tangent line at a specific point. We have a point now. We're really trying to figure it out what the tangent line slope is at negative 1, negative 2. You can't put that into the slope formula though because you'd be divided by 0. So the second point has x coordinate, negative 1 plus h, y coordinate, given by this expression here, but this is more useful to us. And that's what we just figured out, h squared minus 2h minus 2. So the whole goal here was to get stuff to plug into the slope formula. So I'm going to change colors and just say slope is equal to. Now we usually say y2 minus y1, right? I want you to try it a different way today. No, I'll keep it as this. First. Now, I don't usually write out the formula, but I'm going to today, okay? And I think, you know, change in y, change in x. Would it, here's what I'm trying to say, I guess. I'm going to do an extra step, just only to get you thinking about something. Instead of slope, I'm going to just put m. And I'm going to do the under first. Our x value, x2, is, let me use this and do it, negative 1 plus h. Subtract negative 1. Now, I'm going to do this right now. You wouldn't normally do this, but I want you to think about this. Our y values are our f of x values, agreed? And it's just only to get you thinking about this notation. Would you agree that the corresponding, the matching y value to negative 1 plus h is f of negative 1 plus h? I know we have it worked out already. And you're thinking, what mistake did you guys make? Okay. Any more outbursts like that and another balloon gets it. Okay. Now, like I said, you wouldn't normally include this step, but I want you to think in terms of f of x notation because Hashim can assure you too. You do see this f of x plus h kind of notation more and getting you used to this idea. Okay? So, I'm taking a slope. And now I'm actually going to plug in what we have worked out for this y expression. We actually have a number for this f of -1, don't we? You wouldn't normally show this step. I'm just getting you to think about it in f of x notation. So the slope, we can come up with some kind of expression if I put in my h squared minus 2h subtract 2. We have y coordinate of -2, already worked out, subtract -2. Now, I'm not going to do anything to the bottom quite. Normally, you would have worked out and simplified a few things, I think. I'm only showing it this way because typically you would not write this out as a step. You would just jump. This would probably be your first step, right? You wouldn't write out y minus y over x minus x, would you? So this is typically where you're starting from. Something like that expression. So what do you do next? You group like terms as much as possible. You have things multiplied out. Blues and reds can mix together. They're not blood types. We can mix them up. I'm going to just switch now just to one color. So h squared, there's nothing on the numerator that matches with h squared. Minus 2h, nothing else on the numerator that matches with minus 2h. Subtract 2, -2 minus -2, so 0, right? Done. On the denominator, -1, that can match with subtract -1, so add. Zero's out. All we have is h. What do you do with the h there? Can we simplify this a little bit? Yep. Will we come up with a number for the slope, though? No, we'll come up with this dumb expression. H squared, or h minus 2, won't we? Okay. You guys follow me on this? You still haven't solved the problem. You say, like, Shandelka, what good is a slope that's in h's? You're right, it isn't any good. But do you remember at the start of this, what's the whole idea of this h, other than Hashim? What did I say about that h? It's very close to what? Because the idea was, you know, right now we have h here, but we could inch it up and closer and closer. We could do it from the other side too. What's the idea with h? How much are we adding on here when I used examples like 0.99? What would you be adding to -1 if you have 0.9? 0.01. Or 0.99? 0.01, 0.001, 0.0001. What are we doing to that h? We're getting it closer and closer to no, the h value. It'll get the q because how do you get q closer to p? By moving h closer and closer to the number 0.0000. These are h examples. I keep trying h values that are approaching 0. What did we call that when we say, we always saw it with x approaching, no? It's a limit. This is a limit here. So hey, I'm going to just insert something here. To figure out what our actual slope is, and we want a number. We don't want h something. We want a number. So we're going to say now, the slope, to evaluate this, m is equal to the limit of what approaching 0, not Hashim? The h getting closer and closer to 0, 0.1, 0.01, 0.001. Or you could have said h, okay, from the left or the right of 0, -0.1. Now this expression, I'll repeat myself here. You could have jumped and you probably haven't simplified. This looks like a limit we would have done on the test the other day, doesn't it? How do you evaluate this limit? Simplify the expression, right? You can think of it as factoring out the h or distributing the division. Either way, what does this simplify to? H minus 2, and then a -2. Yeah. I'm going to show this 2 steps here. So m equals the limit of, and I don't doubt that you could do this in your head, h minus 2. This is legal. I can put the 0 in here. I couldn't with the denominator having h in it, right? So you can think of this as I factored out the h and then canceled it, or you can think of it as distribute Thank you. So 0 minus 2 is negative 2. But you're saying, hey man, maybe the chart's quicker. Actually, it isn't. You won't be writing out as many steps every time, and you won't have me talking about every step every time. So, is there any question? So a second question. Oh yeah, for sure. Now this second half of the lesson has been brought to you by the letter A and the number 2. And also the letter P. F of x equals x squared minus 3x. We want the slope of the tangent line. So if I was to graph this quadratic equation, drew a tangent line at x equals 2, what the devil would I got? Now this time I left you out a little extra. I gave you 2 as the x value. I have to give you that. But you need the corresponding y value. What is f of 2? We know how to find f of 2, I hope. So f of 2. I'm going to operate in regular. So we know if I'm going to say x1 is equal to 2, right? Because I'm giving this is my point. y1 is equal to f of 2. Plug 2 in. So what is that? That's 4, 2 squared, minus 6. 2 comma negative 2. Y'all dig that? So going back up to the top, point P is really 2 comma negative 2. Then, we're going to use that H the exact same way. So our point Q that little dot that we're bringing closer and closer. I don't care. I don't even have to know where on the function it is. I just know that Q is going to be very close to P. So its x-coordinate is, well, it's going to be very close to 2, right? But to say that it's a little bit off of it, what did we use as a variable? We'll continue using the same letter. That H, right? That little 0.01 or 0.001 and eventually 0. 2 plus H. We're kind of tricking the math out here with this limit idea here. You can't really divide by 0, but we'll get around that problem. Now, it'll have a corresponding y value. I'm getting used to this notation thing, though, really. I'm plugging into the function, 2 plus H. And that'll be the y value that's very, very close to the negative 2. So we've got to put this 2 plus H into the original expression. 2 plus H squared minus 3 times 2 plus H. Now, first term, there's going to be 3 things. 2 plus H times 2 plus H. So we'll see if we get the same thing. You guys work this out, see if we can group for like terms. I'll stand in front of the board. Take a moment. If you're watching on video, pause for a second. See. Now, I've worked it out. Hopefully you guys have too. This is what the square turns out to be. Don't forget, minus 3 times 2 is negative 6. Minus 3 times H is subtract 3H. That's a common error too. Anyways, group like terms. If it makes you feel better, put the H squared first. If it doesn't bother you, you don't have to keep it first. So we're not going to factor this. Now what do we do now? We're trying to find the slope of the tangent line. So that means we use the slope expression, right? So the slope is equal to. Now, the last time I threw it in as a last step when we couldn't get any further. Let's just throw it in now because we know that what's the idea of H? It's going to get closer and closer to 0. So I'm going to throw it in right now. The limit of H getting closer and closer to 0 for this big old expression. I'm putting that in black. I'm going to use some different colors here. Now, y minus y over x minus x. Well, I'm really thinking of f of 2 plus h minus f of 2. I'm not going to write that out, but that's what I'm using. So I toss in the h squared plus 2 minus 2. And I am subtracting the corresponding y value, minus negative 2. I'm going to change something now. I do that in red, but I'm going to do this black here because that's built into the slope formula, that subtraction. That's why we're subtracting y minus the other y value. X, x2, 2 plus h. I'm going to put a bracket around it because I just like it. So you can see where the chunks come from. Part of the slope formula is minus, and then it corresponds to a x coordinate of 2. We're going to do some arithmetic. Still not evaluating the limit, because if we tried to right now, you quickly see you'll get divided by 0. That's rubbish, right? Actually, it's indeterminate form. We get 0 over 0. It means we have to keep working it. This slope is going to be equal to the limit as h is closer to 0, 4. Now I'm dropping the color scheme. H squared, nothing else to match with. Plus h, nothing else to match with. Minus 2, subtract negative 2. Zero's out. 2, subtract 2. Okay, it's gone. H is all we have on the bottom. If you don't get an expression where the h is, now you can see you're going to get the denominators h to cancel out. You've probably made a mistake. Go back, check. Your most likely error is when you squared this kind of thing, if that's the case. Your other likely error is way back here. You know, did you pull through all negative signs as you did things? You probably made, well, you made an error somewhere. If you don't get a scenario where you can quickly see, oh, I could divide this h, distribute the division, or factor out the top and cancel the h, whatever you want to think of. So I'm going to write this out explicitly. If you want to jump straight to evaluation, you can. H plus 1 when we simplify. Hey, I can evaluate this, can I? It's 1. 0 plus 1 is 1. The slope of the tangent line at 2 comma negative 2. If I drew out that graph of that quadratic, I would have a slope of positive 1. That's what we're talking about, the slope of that line. Now, I didn't draw it perfectly. But if you were, like I didn't draw it on a grid, but you get the idea? Tangent line, slope, it has a steepness of 1. If it's at some other point, over here or something like this, it'll be a steeper slope. Over on this side, it'll be a negative slope. At this particular point, 1. Now, I've asked you to do 2 questions. It's not an onerous task. Try those. So, as mentioning, with these questions, when you find the equation of the tangent line, I only showed you the calculus. The new thing, you find the slope. Once you have the slope, you go back, look at the point that you were actually interested in this case, for example, negative 2 comma negative 2. And use the point slope formula. What's the point slope formula, you say? Well, it's y minus y1 equals m x minus x1. I expect you to know that. That's not calculus. Once you have the slope, you're done with calculus. Solve for y. These examples have slope-intercept form. Okay. Over and out.